Okay, so I really don't know what I'm streaming. So I realized that I've been talking for like 22 minutes and no one could see that. So that's a face palm. So I was wondering why no one was responding to anything I was asking, but yeah, I feel dumb. So you missed the whole setup. You didn't really miss anything interesting other than stuff working, but now I feel kind of silly for explaining stuff to myself. So I'm actually gonna go take a minute and I'll come back in a second. I'll be back in like 2 minutes. Sorry for everyone that has seen nothing because I started the stream and I can see the preview in the YouTube stream, but I didn't hit the big button that was go live. So I'm gonna take like 2 minutes, go grab myself a soda because apparently I'm not awake enough, and then I'll come back and I'll re-explain all the stuff that I now have practice on explaining. So I'll be right back. Okay, I'm actually back now. So, funny story. First was having a ton of problems with OBS. I guess it updated at some point, and I don't have a local preview, so I was trying to get things working, and yeah, and then I started previewing. Oh, I need to uncover my webcam stream. You can tell I'm out of practice at this, and I'm it's been a while. So and then I didn't hit the go live button. So I was just talking to myself for about 25 minutes, explaining how the stream works. But yeah, so I'm back. So thanks everyone who's still watching or has started again. When you can actually hear this, I would appreciate if you say something in the stream. So if I don't see anything in like 5 minutes, then I don't know what I'm gonna do. But do me a favor, and either in the Matrix chat or in the YouTube comments give me some sign of life, please. But yeah, so what I've been working on lately, let's do that, because you didn't see any of that. So I've been working on two libraries lately. So I've been working on one called CMM, which is okay, cool, someone can hear me. I'm not broadcasting into the void again. So there's two libraries I've been working on. I'm working on CMM, which is Cortex-M interrupt move, which is aiming to be a solution for sharing data with interrupts. Sharing data with interrupts without using what we call the mutex dance, which is when you use like a ref cell mutex option of a type just so you can send data to an interrupt, or using something like RTFM, which provides a lot of cool tools. But if you're just trying to share a little bit of data with an interrupt, and you don't know RTFM yet, I would recommend you learn RTFM, because it's an awesome way to build a Rust application, and I use it in my Internet of Stream stuff. But if you're just trying to share some data for like a quick proof of concept, there's not a pleasant and safe way to do that, and CMM aims to fix that. What it is it's kind of like a mutex that you can put at global scope, but one, you can initialize it late, so kind of like lazy static, you can initialize it at runtime. And two, it doesn't require a critical section or turning off all of your interrupts to access it, like the Cortex-M mutex does. So the way it works is you can declare it kind of at static scope. Notice that it's not mutable, so it's not unsafe to deal with because it has inner mutability. It's going to hold whatever data you want it to hold. You give it the interrupt type, so all the different chips have different interrupt types because they're auto-generated by SVD to Rust, so you got to tell it what kind of interrupt you're going to use. And then you just say, hey, this data is going to be used by specifically the UART0 interrupt or the ADC0 interrupt. You can either initialize it late, like this. New uninitialized means I'm going to initialize it at runtime, or just new means I have the data right now, I can make it in a const context, and I can initialize it now. So then for the late stuff, you go ahead and you initialize it by moving the data. So this actually takes ownership of the data that you give it. And then it will give you back the data. If there was something, you initialize it twice, it'll give you back the old data, but you just need to initialize it. And this has to be in the non-interrupt context. So basically this is where that error could come in, is you're not allowed, at least for now, to initialize it in interrupt context. So the idea is that you do this at the very beginning of your program. Yeah, and this one where I already initialized it, if I give it some new data, it's going to give me back an okay sum the old data. Then you would enable your interrupts, and then this main loop doesn't do anything anymore, and in your interrupt you can actually lock the data and get access to it. So what I did after that was I pulled one of the examples that I've been putting in that CMM repo, and this is a simple example that's using the DWM 1001, which is a board that I've been using for the Internet of Stream stuff. It's what my company, Fair Systems, uses for our embedded trainings. It's based on the Nordic NRF52, which is a wonderfully pleasant chip to work with. But what this does is it moves some data into the timer interrupt. Let me full screen this. So instead of making a bunch of these, I just made one struct that holds all of the data. So this is everything that's going to be handed to timer 1. Made a CMIM move where it's going to take this kind of data. It's going to be late initialized. Here's some notes that I was talking to myself. So what it does is it starts up the timer, it initializes it, it gets the UART from the board support crate, it grabs all this stuff, it grabs an LED, a little configuration variable, throws that all in a struct, throws it to the interrupt. Cool, it's moved out of normal context, moved to interrupt context. Then the normal just main or thread context is what it's referred to in Cortex M, but basically like non-interrupt context. This is just going to blink an LED. Now it says once a second. I was in the middle of messing with stuff. The original thing did let me just put it back. You know what I can do is I can git stash. This should be back. Luckily I made myself a little git repo. Git stash pop. I didn't save any of the stuff that I was doing here, so let's do this again. Cool. Now this is back. This is the original example where thread context is going to blink 4 times a second, so every 250,000 microseconds or 250 milliseconds or quarter of a second. Our timer interrupt, every time it fires, is going to clear the timer interrupt, basically stop the old timer, start the timer again for 1 second. It's going to print some stuff out on the UART, and with the NRF52 you have to send data from RAM, not flash. So I explicitly copy this in because if you have a non-mutable variable, the compiler is very helpfully going to go, oh, that doesn't change, I'll just stick it as a constant in flash, which doesn't help you if you try and send it to the port because that will cause problems. So it's going to send the data over the UART, it's going to blink an LED, it's going to update the state variable so it knows which one to toggle, and this was all inside the access to the data. So basically you just have one lock on the outside of the interrupt that says give me the data. It's not locking like a critical section, it's just saying really this lock is just checking, am I in the right interrupt? Does this, where I am right now, match this? And the answer is yes, so it's going to be fine. If you tried to call this from like timer 2, then it would return an error and then it would unwrap here, which would be bad. But we're in the right one, so it's going to work. So let's go back and do this. I've already started. Let's go ahead and clear this so you can kind of see it going. Start a serial console. I'm already connected to my debugger, and because I have a little bit of magic in my cargo config that says, hey, when I tell you to run GDB for me, and I have a GDB script, so it's going to connect to my debugger. It's going to load the software, reboot the device, put a breakpoint at main, and then run until it hits main. So basically this is just going to stop when I hit the first line of main. So now if I do a cargo run, automatically loaded the software to my hardware, stopped at main, I've just got the power LED on. If I hit run, you're going to see one light blinking at once a second, and you're going to see another light blinking twice a second because it's toggling every 4 seconds. I guess this is blinking every 2 seconds because it's toggling every second. But we can also see on our screen once a second you get the word blink printed out. So this is kind of a working example where yeah, I'm using interrupts. So hopefully that blinky light's visible. Someone is asking, is anyone doing Rust on a Teensy 4 here? I don't know if they're in my chat, but there definitely is. But I'm realizing that person's probably not in the chat, so they probably can't hear me, and I'm not going to go type. So yeah, this was a really simple example of this working, which is lovely. This is actually one of the examples in the CMM crate, but I just copied and pasted it because it's a relatively recent example that I had sitting around. So, one of the things I said before is normally Internet of Streams is working on one big project. I haven't touched it in 6 months, so if I were to dive back into it now, it would basically be half an hour of the stream of me remembering how my own code works, and I decided to skip that because I've been working on some other stuff lately. So this is kind of like a brief break on the normal Internet of Stream stuff and just working on other random Rust stuff that I've been working on lately. So that was the first crate. That's CMM. What I was trying to do right when I realized that I wasn't streaming was I was going to integrate BBQ into this example. So BBQ is another project of mine, which is based on a bit buffer queue. So the name's kind of somewhere between barbecue and bit buffer queue. What it is, it's kind of like a circular buffer, but instead of pushing one thing at a time, kind of like there's heapless SPSC queue, which is a really cool circular buffer that if you can push structs at a time or a byte at a time. But if you're handing something to DMA, you don't want your DMA engine to put one thing at a time in your circular buffer, and also your hardware knows nothing about heapless's queue structure. So what you want to do is you want to give it a whole chunk of bytes and say DMA put some data here. BBQ lets you do that. You can basically break off a chunk of the circular buffer. It guarantees that it's going to be a continuous range of bytes so that your DMA engine can use it. And then whenever your DMA is done, you can commit the whole chunk back to the circular buffer at a time. Doesn't require heap allocations. It's still using the same circular buffer, but it makes you a first in first or FIFO thread safe queue. Yeah. Someone is asking, will I be streaming regularly again? No commitments. Probably gonna have some more time, especially over like Christmas and stuff like that. So I would expect a couple more streams before the end of the year. I run a company called Ferris Systems that does consulting around Rust, and all of my time generally goes into that, or trying to expand the embedded Rust ecosystem, or hanging out with my family. And I've got a tiny dog. I guess he's like a year old now. So no guarantees, but I'm gonna try and stream more because I really enjoy streaming. It's just been hard finding time. So if you yeah, I'm gonna try. I promise to try. No guarantees because other stuff kind of takes priority. But yeah, it's fun to get back into streaming again because I enjoy it. But yeah, BBQ, this example's totally wrong because this is still the old interface. I've been in the middle of a rewrite because there's been a couple things that were like paper cuts in terms of usage, a couple things that were technically unsound, and if you use them in the wrong way, then you could totally get undefined behavior. Yeah, so there's been a bunch of paper cuts. It's generally worked pretty well, and I know some people are using it for some stuff, but there have been some things that I've wanted to fix but had no idea how. I'm going to kind of put my body in front of the camera right now and close my window because it's getting cold. I needed some fresh air there for a minute, but too much fresh air. But yeah, for like 6 months I've been wanting to fix it but haven't known how, and then I had kind of like a shower moment and talking to some other people and kind of sitting and thinking about something, and I came up with an idea of how to make it better. And so BBQ version 0.40 is kind of that rewrite. So it doesn't look like this. It used to look like you would use a macro and that would statically allocate something. Yeah, let's just go look at what the new code looks like. So this is what the new one looks like. So you make a new BB buffer, and then you split it, and that gives you a producer and a consumer. Totally exactly the same as kind of like every other channel or queue or whatever. The difference between like a regular channel or queue and BBQ is in BBQ, either reading or writing is a two-stage process. You get a grant. A grant says, break me off this chunk of the ring buffer. So it gives you ask for it. And so if you ask for 12 bytes, it will give you 12 continuous bytes. And those are yours to write stuff to. And you can't read that yet because you haven't committed it. So you get the chunk broken off. You can take as long as you want to write whatever data you're going to in there. You can hand it as a pointer to the to a DMA engine or something like that. And so here kind of I take a grant of 1. I write the data. We see that the amount of data that I was given was 1 byte. And then whenever I'm done, whenever I'm ready, whenever my DMA is complete or whatever, I can commit up to the amount that I was granted. So I can ask for 100 bytes and only say, oh, only the first 50 of those were good. Maybe my serial transaction ended and I only got 50 bytes. So you can commit as much as you want. And as soon as you commit it, it becomes available for reading. And reading works exactly the same. When you ask for a read, it gives you all of the bytes that are ready to read. This could be useful if you're going to send it on DMA. So you can read that data. Here we're checking that, yes, the first byte that I was given was 123. And then you can release kind of the same way. You can release as many bytes as you want. So maybe there were 100 bytes ready, but you only wanted to send 50 over the UART for now. So you only release the ones that you're done with. And once you release them, that makes them available for writing again. So you might have a buffer that's 1,000 bytes, and you can break off chunks of 100 at a time, and it's just going to keep giving you those chunks. Although if you ask for a chunk of 100 and it's full, it will say, nope, you can't have any right now. Sorry. There's some special stuff around how it handles wrapping around the ring buffer, because it also guarantees that if you ask for a chunk of 100 bytes, it will give you 100 continuous bytes. So if you're at the end of the ring buffer and there's only 50 bytes left, it'll actually jump back to the beginning, kind of ignore those 50 bytes and give you the 100 bytes that are at the beginning of the buffer. I wrote a blog post about this. I thought there was a link. No, this is the C and C++ one, which I looked at, and I don't think is sound without a mutex. Fine if you're using it single-threaded. Probably not good if you're using it multi-threaded or with an interrupt, unless you're really, really careful. I worked on this at CCC over the 28 or the CCC last CCC, the most previous one, the one that was like 11 months ago. I worked on this with some people, wrote up a good blog post about it. It's on the Fair Systems blog and on a couple other places, so check it out if you'd like. That gives like the whole explanation of how the concept works if you're interested, but basically I have a new interface for it. So I've been working on that. Also added some compatibility this uses atomic compare and swaps, which is really nice if you're on a Cortex M3, M4, 7, 23, 33, because you can do this without locking at all. Like, it doesn't require any mutexes or locks or anything like that. It does it totally with atomic compare and swaps on data. Problem is, if you have a Cortex M0 or an M0 Plus, you don't have those. So I also made a version that works with Cortex M0 and M0 Plus. It does require you getting a critical section every time you kind of request a grant, commit a grant, something like that. But if you're on a Cortex M0, this is possibly one option for you. Yeah, so what I was going to do is I was going to edit this example to just also use BBQ. What I said I wanted to do today over the maybe 2.5 hours I have left, I wanted to, I need to pop. Let's go back to what I had before. So my goals for today was to test CMM and BBQ because I've been working on both of these lately and I just wanted to play around with them on hardware to make sure that my code actually works. I have a panic handler crate that I kind of had an idea for. The real prof in the embedded working group has this awesome crate called Panic RAM Dump. Which is really cool because when you panic, it just blows away your whole RAM and writes the panic message to like the beginning of RAM. So if you had some stuff there, it doesn't care. It's just going to copy the panic message there, but then it sits there in a loop. So if you've panicked, you can attach a debugger and just print the data that's at the beginning of RAM, which is really cool because it lets you get these panics without using semi-hosting or something. Basically, it's just a mem copy of the panic message to the beginning of your RAM. I had an idea where this is nice, but the problem is that it's going to blow away whatever data was in RAM already, which sometimes is okay, but if you wanted to debug that, it's going to be hard. And it doesn't help you if you're in production, basically. Like, if you panic and it just goes into an endless loop, that's not good because you probably want your device to reboot and start trying again. Like, if you had a smartwatch and it just, like, panicked and didn't do anything, that probably wouldn't be good. But I had an idea to essentially reserve a chunk of memory in RAM so that you have... hey, everyone in chat. Thank you for watching. If you have a reserved chunk of memory in RAM, to exclude that from the BSS region. So normally if you have like a chunk of RAM that you use for variables and stuff like that, it's specifically in the BSS section. When the device powers on or resets, it zeroes out that whole chunk. This is so like your static variables get the right contents in them. They start with a sane default and stuff like that. There's a couple steps, but most RAM is just going to be zeroed on start. That's not good if you want to preserve some data across reboots. So what I wanted to do is modify the linker script so that you have like a kilobyte reserved for error messages. If you panic, write the panic message to that reserved kilobyte, and then on boot you can check, hey, is there any data there? And if there is, you can get back a reference to it so that you can print it out to a UART. You can send an Ethernet packet that says, hey, I crashed. here's the reason, but I'm going to continue doing what I'm going to do before. I open it up as a PR or an issue really to panic RAM dump because RealProf already had most of the parts that I needed. I'll probably do this in my fork. I don't know if I'm going to PR this yet, but I use some cool tricks like I use a magic word to determine if there's actually a message there, because if you're coming from a cold boot, you're not going to have that data in RAM. The RAM's going to have evaporated. But if you put something there and then do a soft reset, dumb question, are these tools like dumping RAM also possible when using C? Yes, you can totally use GDB to dump RAM, whether you're using C or Rust. Yeah, you would generally use a debugger. So something like this GDB window that I had open, you can use to just print kind of the same way that the RealProf's example works here. So if you wanted to just dump, if you have a GDB window, you could say XS, which is saying print me the stuff that's at this address, and specifically it's going to be a C string. So it will print the C string. So it's just going to start at this address and go until it hits a null byte. But you can also use, like, you could dump the whole region of RAM. You can do whatever when you have a debugger attached. But what I would like to do is not that. Let me go back a little bit to my PR. So the idea would be that you like specify a region that's like, hey, this is where I'm going to put my panic dump stuff. Like it's 1 kilobyte. And then put a magic word there. So what I was saying was, if you put a magic word there, if it's going to come from a cold reboot, like you crashed and immediately rebooted, the RAM's not going to reset. Like RAM doesn't magically reset unless you do it. Normally that's done by like the Cortex-M or Cortex-M runtime crate. If you're in C, it's done by a file called CRT0, which is normally linked in by your compiler for you, which just like sets up the memory regions the way they're supposed to be. But what I'm saying is, if you omit that, it's not going to get zeroed on boot, which means if you're coming up from a cold boot, it's probably just garbage, or maybe all zeros or maybe all ones, but probably not the magic 32-bit value that I chose. So if you reboot and that magic value is there, then that means that the memory is going to be stuff, or memory is going to be a panic message that you want to keep. And you can decide as an application writer, how do I want to handle that? Do I want to flush it to flash? Do I want to send it in an Ethernet packet? Whatever. So I want to work on that. And the other stuff is implementing some interrupts for the NRF52. The NRF52 has a lot of drivers in it, or the Rust NRF52 hardware abstraction library has a lot of drivers written for it, but very few of them have interrupt support. So I want to change that because, yeah, I want to do some interrupt driven things for the NRF52. Right now, I think the timer might be the only one that actually has an explicit like interrupt interface. So I want to change that. I want to at least make like the serial port DMA driven. I might make like the SPI port DMA driven. I definitely want to make the GPIOs interrupt driven, so I can do stuff like read a button in an interrupt, or even toggling a GPIO from an interrupt, which would be cool. I guess I could probably do that without, but yeah. I also have some like got a bunch of these little NeoPixels. I went to China and I came back with just a panel of them, like 100 of these. So I want to write a little NeoPixel driver. I know there's actually already a bunch. There's the Smart LEDs organization, but I also want to write a little interrupt driven one that's based on a driver, or based on an interrupt timer. Okay, let's actually write some code instead of just talking. So I was in the middle of adding BBQ to this. So I have my BBQ. Let's go ahead and make my BBQ. I've got my docs here. So this uses a little trick that lets me construct this as a constant thing. I won't explain that now. Maybe I'll come back to it. It's the same trick that the heapless crate uses. Buffer. Let's give it a kilobyte for now. BBFR const BBFR. And this is basically that you can't do some things in constant context today because it's not stable, but it will be soon. So let's get those constants and let's see. Expected const, right? Not the type. Let's call it Buffy. Buffy the buffer. Cool. So I have this. So what do? I'm going to have this. I'm actually going to have my timer is also going to have, it's going to have what? It's going to have producer, consumer. It's going to have the consumer. Data is going to be a consumer. I think specifically, what does it complain about me not giving types for? You want a lifetime and a type argument. Okay. You're going to have static lifetime, and you're going to have, you're going to be a consumer of 1024. Missing data. Yeah. Let's split that. So let's set up our buffer. So this is going to be Buffy dot try split unwrap. I know this is going to work. See, I don't really need a mutable consumer because I'm going to pass it. Cons. Cool. So what are you gonna do? I'm gonna change this main loop. Instead of going 4 times a second, once a second, it is going to toggle the LED, and then it's going to, I need a big chunk of data. Okay, let's make a big chunk of data. Hello, this is me sending data on the stream to my DMA UART. This is 60. I just want a lot of data. This is more than 1,000 characters. How many characters is this? This is 915, 975. I think this might be too much. Yeah, let's just do this. This is slightly less than the right number of characters. Let's put this down at the bottom where no one cares about it. Const. Actually, you know what? I don't want to send all of this. Let's send something like, let's send something like 1/3 of that. That should be fine. Const message, which is stir equals let's see if this works. And then, so every in here, I'm going to do prod dot grant message dot len. So I want a grant that is the size of message len on wrap. Let's just if let okay g equals this. Let's just, in case it doesn't work, let's see. I have a grant and I want to copy it, so g dot dot message dot len. So I take a slice. Well, actually, I know that my grant is this exact same size as my message, so I could just do g dot copy from slice message g dot commit. So what I'm going to do is I'm going to copy the data to the slice, and then I'm committing .len. I'm going to commit the whole region. expected slice found stir. Oh, right, as bytes, because it's a stir slice, and this needs to be a mute G. Cool, and I got my consumer. So this is gonna end up being blocking, but that's okay. This isn't gonna be perfect. We might see some hiccups. This is really just a demo that everything works. So instead of blinking, what I'm gonna do is I've got data dot, oh, I've named this terribly because it's data dot if let, what is it? It's an option. Okay, read grant equals data dot read. I know that the NRF52 or the 52832 will specifically take up to 255 bytes at a time for a DMA transaction. Yeah. This is blocking though. Like I said, we don't have a non-blocking one yet, so this is a blocking version of this. So we're gonna block, but we're just gonna block for a little bit. So I'm gonna write the data from the grant. Once that works, then I am going to okay, because read grant will give me everything that's available. So at the beginning there might be like 300. There's gonna be a bunch of stuff, but there is core comp min. So let's grab use core comp min. Let len equals min. I want the min of g.len and 255. So whichever is less, 255. So if you have more than 255 bytes, it's going to take 255. And then if I have less than that, it's just going to give me the length of the grant. So I don't need any copy from slice. Oh, I'm doing this in the wrong place. Helps if you do code in the right place. Read grant.len. So you are right. The grant from 0.len, we want that many bytes, and then we want read grant.release len. You meant, so Carlos is asking, I meant placing the string at the memory location. Yeah, C could totally do the same. I don't know if I've seen any libraries that do that, but if C had a concept of panicking or just like when it crashed or something, it could totally decide to, I mean, it's essentially doing sort of like a core dump, only instead of reading the registers and stuff, it's a panic message. So let's see what our compiler thinks of that. Producer is never used. Yeah, I guess I never had to manually. So now what should it do? This runs at once a second, so we're gonna have one LED that's blinking. I think the blue LED is gonna, 10, blue. Blue LED is gonna blink kind of slowly. The green LED, if I remember correctly, is gonna blink 9, green. Green's gonna blink pretty quick, every 50 milliseconds. Maybe slightly less by the time that I write some stuff to the UART, but let's see how this, you know what, let's give myself some numbers so we know. Okay, so now we have, and let's throw some white space in there. or run. So this is running, and I see some blinking. Oh, yeah, let's. Don't want an R string. Let's just do this. Let's just do the return in there and see how that goes. Expected square bracket. Does Rust support this? I guess. I don't remember how multi-line strings go. R syntax is a way of doing string literals that contain stuff that they're not supposed to. What do I need? I need quote hash. Will this? I don't remember if there's a way to escape this. How do I get multiple lines at the same time with escape characters? Rust R string tab. Let's raw string literals. This is like this. Yeah, they're used a bunch when you're putting data in line. Thank you, Rahul, for writing a handy guide. I want. They're really cool because you can just keep adding hash marks. Quote. Yeah, I guess I can't. Rust multi-line string literal. I thought there was another one that isn't. Oh, all string literals can be. Now, I'm overcomplicating this. I don't need any extra characters. I just need this. Haha. PUF. Nick Ray, what is a PUF? Cool. So you can see that even though I'm eating like chunks of 255 bytes at a time, and this is definitely more than 255 bytes, that it is letting me send data, and I can make a much bigger buffer. Let's make it like 4096. And let's see, how many bytes is this? This is 397 characters. So let's how many bytes are you? Let's throw another one in there. I want to keep it under half the buffer just because the buffer, if you don't give it room, because it's wrapping, if you get it to the point where you're like 3/4 of the buffer, it's not going to let you add anything else. Normally there's some other functions like read grant or grant max, which lets you take like a subsection of buffer, but right now I'm just using grant, which says you must give me exactly these many or it will not work. Although I guess I have an else in there. Let's see, main rs. So if it doesn't let me push stuff, oh, it's just gonna move on. Oh, then fine. Yeah, let's make this huge. At some point, it's not going to be able to keep up, but okay, we're pretty close to 4096. Okay, Let's make these 0. Just so I can see, and let's call this 7, 8, 9, 10. That many? Nope. 1, 2, 3, 4. 1, 2, 3, 4. I'm not doing this right. Whatever. I got a new line in there. We can tell the difference. Found type. That is certainly an interesting error that you've decided to make. Oh, I know what's up. Because this one's 4096. Yeah, the problem with type num and not integer generics is they don't give very helpful error messages. They're not the best user experience. They let me use things now, but basically version 1.0 is not going to be there until const generics land. Oh, did I not include an extra new line? Let's put some extra new lines in there. So you can see it kind of chews through that. Oh, look, it's probably left itself in an inconsistent state where there's now no room to wrap around because it's probably left a hole right in the middle. Yeah, I shouldn't have done that. Let's make this a smaller chunk because then it will probably work. Because it's basically, yeah. Because if you have like a dead space in the middle of your ring buffer, then there's no place to put more than half. So if you're ever trying to put more than half in a circular buffer at once, it's not great. So yeah, there we go. Sending that kind of like 255 bytes at a time, which is kind of cool. This UART's only going at 115200 because you could make it go up to 1 megabit, but it starts dropping characters like crazy. It's probably because the microcontroller is hooked up to a debugger chip, and the debugger chip probably just can't keep up with it, or it kills the USB line or something like that. Let's see, I've got just double checking some stuff. Okay. Okay, so this is enough of this. So let's get add -I update little BBQ example. Let me go find. I've got this. This is for me. Fancy. Let's go ahead. Let's play around with some. Let's play around with some panics now. Let's clone. Never mind. Let's see. Okay. So now we've got this panic crate, and actually let me panic ram dump. Let me add this to my dependencies, so I'm no longer using panic halt. I'm gonna use I don't remember what the version is. 1. Cool. Let's just what does my panic ram dump look like right now? Does it have, is it on master or is it the thing that I did? It's on master. Cool. So I'll show you what this does. So this is going to be panic ram dump, panic provider crate. Never leave home without one. Panic at the disco. Could not find target. No panic RAM dump external crate. That's not even true. Now it's true. Cool. So we're gonna blink, we're gonna wait a second, and then we're actually gonna panic. You can see the blinking on my LED has stopped. So if we hit here, we can see that we are in panic. So if I do XSOX, 5S, I can never remember. What is is it because I'm at the wrong memory address? Let's look at my target. Thumb debug. Build directory for Cortex MRT, probably actually NRF52 HAL out memory X. What is my, yeah, my RAM starts at 2000. Okay, what do you... Why is my length 0? Panicked at, okay. No, right, can't step into that. I'm in mem move basically. Well, I got at the disco, which is nice. Destination. Why are you at a kilobyte off? What? Source is here. And destination's there. Okay, let's... I can't remember what I need for obj dump. Let's do XCL. None ERB obj dump XCL target thumb debug. Where is my SPSS? I don't, why did you decide to put SPSS there? Okay, cool. So SPSS is just start of BSS section. I would totally expect it to be here. Oh, I guess the data section's there. Huh, interesting. Okay, so let's try this again. So I'm definitely panicked now. Now if I try doing XS, panicked at the disco. Cool. And because we don't have null terminated strings in Rust, it's just going to see some garbage until it sees the end of it. So this is kind of the existing behavior of it, is that we can see that we panicked at the disco at source main 109. So if I go and look at main, line 100, column 9, so this is where the panic is. Lovely. But that only helps us if we are, the heap size 1024. I don't think we typically set a heap size. Let's go look at that. What is there? There is S data. So start of the data section. Data section is our statically initialized. It's the like data that gets copied into static variables before you use them. It's 1024. Oh, it's 1024 hex, which is even weirder. Oh, that makes sense because I have a giant 4K section which is being initialized to 0 in my buffer. So yeah, it's probably my buffer. So if I go and look at if I go, let's control home, alt home. No, less commands. I don't know what I'm doing here. Let's go look at the top. Yeah, Buffy is taking up 20,000. It really shouldn't be, because it should be zeroed BSS data, but I guess it's deciding that this needs to be filled with zeros explicitly, which is unfortunate and kind of a waste of data. Const generics, I want you to be here. 124. Okay, yeah. It's unfortunate, but makes sense. Okay, so now I want to go increase the size of this. CD stream 2 git checkout fancy was the name of my branch. Do you build? I think I just kind of blind wrote this. So if you're in the stream, do me a favor. Let me know what kind of Rust stuff you're working on. If you're working on any projects right now, that's awesome. If you're just learning, let me know that you're just learning. But I'm interested to hear what kind of stuff you are doing in embedded Rust right now, or what makes you interested in watching me program some embedded Rust. So I'm looking at the stream comments, so feel free to share if you'd like. Okay, so this does build, so we can look at kind of what I did instead. Let's go look at this. So I basically hacked up the real profs crate, and the idea was that you define some symbols like panic dump start, panic dump end. They'd get picked up on. Yeah. So you should be able to do this, and it will write. And I think this is, well, you know, I wrote this blind without testing it. I kind of want to, let's just run it. And I'm almost certain that there's undefined behavior in here. So let's borrow this. And I think, let's just go over here. What happens if I, okay, so I've got flash and RAM, length 64K. So let's make it 63K. And because I can't do math, OX 20 bazillion D plus I have 64 times 1024, 64 kilobytes. Yeah. But 63. FC00. Cool. If I do 64 just as a sanity check, yeah, that makes sense. FC00. So RAM origin is still in the same place. Length is 63K. And then let's have another one that I just call pandump, which origin equals to FC00. Length equals 1K. Yateki is giving me shit for drinking soda, but it's not Coke, it's Fritz Cola. It's German. That means it's good for running. Pandump for panic dump. This alignment is going to bother me. Not that alignment. And then I think I can just define symbols that are, what did I put in my pull request? Pull request. I think this is generally syntax that is reasonable. I think I can put it here. I think the build scripts are smart enough to pick up on this. So now I'm using pandump. It did rebuild. Although it's now going to reset. So let's modify our crate a little bit. What do I need to do? What is my interface? This is just like code that I blindly wrote to make an example. And let's see what happens. So before we move the UART, if let some message equals get panic message, and I want to steal this. Get panic message. If let some equals get panic message. Let's do my, I know this is coming out of RAM. Actually, I think, to be honest, I think the UART's smart enough now where it will chunk things itself, but let's just, I'll just steal this. I'm just gonna grab whatever the first 255 bytes of the panic message are. Message. Let's just wait an extra second here. Sure, let's just blind run code. Data not found in the scope. That's cool because it's still a part of board. You'd think I'd learn. As bytes. Okay. I can't type. This has been a real, barrier to my career as a software developer. Okay, I would expect there to be no message this time. That was a thing. This is interesting. so it's probably panicking somewhere. I want to know where you're panicking though. Let's comment out the enable interrupt stuff. So let's never enable that interrupt. So we're going to move some stuff to it, but that's fine, but we're going to panic anyway. I just want to see the point where it's panicking. Step into. So start pointer is panic dump start. I have p panic dump start. Okay. P start putter. Okay, cool. That looks like our start pointer. Core pointer read cast usize. Oh, I wonder. Well, I mean that is aligned. If facade does not equal. Huh. I guess it does. What if I do a word ox x word x ox20 fc00 facade. Oh, cool. So it actually did panic there, which is interesting. P max len 1024. Cool. That's the size of my region. P max len stir. I guess, yeah, I have a length word and the magic word. Okay. Looking good so far. Let len cast next. P len 92. That's not bad. If len is greater than max len stir. Nope. Byte offset len. So we made a byte slice of it, or a char slice of it, and then we magically make it a string unchecked. That's fine. Message B as bytes. Sure. Sure. 92. That's totally reasonable. Has it been... Huh. So that worked. Panicked at called result unwrap on an error value. I mean, it's not a super useful output, but... So why was it crashing before? So that makes sense, because if it's panicking. Okay, so, but why does enabling the interrupt? So what if I go back and... So what happens if I just do a Control A, quit? What I'm gonna do is I'm actually gonna plug in my device. I don't remember which one of you used the reset switch. There's two buttons on here. We'll figure it out. At the disco, cool. So it is not that one. This one is. So let me print something out. So I'm gonna actually Control A, quit. So not plug, I'm gonna plug it in with the device held in reset. So the first time it boots, 1000, nothing, panicked, panic, panic. Alright, so actually the crate actually super duper works the way it's supposed to. Look at me blind writing code. I'm not getting my new lines, but that's kind of just the console not being good. I should be using a nicer console that automatically line feeds, but what are you gonna do? There we go. Oh, and it's not gonna like that I don't have a server attached. It's all an error value. Where does it get an error value? Who's unwrapping an error? See, the problem is I don't have a backtrace. Begin on, was it panic? There's like panic begin unwind or something like that. Because I bet you it's like right here. Yeah, so let's just break in the interrupt. What? Fac active. So yeah, we're in the right interrupt. What? Why is it uninitialized? Enable interrupt. Oh, because the interrupt fires like immediately. I definitely need to initialize the data after. Haha, look at me. My code is working. It's panicking because I hadn't enabled it, and probably because we were coming out of a cold boot, the interrupt was probably pending. And so as soon as I enabled it, it immediately fired, and that was a problem. Borrowed. Why is that not borrowed? Oh, right, I can't start it until... Interesting. This is a problem with the NRF interfaces. There's no way to clear this interrupt without a... I can't move the timer in there without... Well, you know what I can do. I can... Huh. No, I don't think there's much I can do on that. That's probably a problem with the interface. I don't know why we make it take the... I can't clear the interrupt without having the interrupt. Oh well, this is a problem for another day. I don't know how I would fix that. Because what I need to do is actually clear the interrupt. Actually, probably in the enable interrupt function. Do I have that? Go to definition. Common. We should probably interrupt. Yeah, because we set the we should probably clear the interrupt first, essentially. Like we should just cancel. We should clear We should clear the events when we enable the interrupts just to clear any pending interrupts. Okay. That's a to-do list for another time. Well, what I could do here is enable the interrupt. Okay. Well, let's just do an if let here. Alright, it'll just keep firing in that interrupt until it has a chance to clear it. Oh well, that's a hack, but 1,000. Where are you? What are you doing, code? Oh, it's just sitting here and like smashing the I shouldn't be doing this. If bad. Nvic disable interrupt timer 1. Nvic comes from here. I don't really need to do any of this. Pack Nvic disable. Oh, it requires access to it. I thought there was a method like pend. Is active, get priority, disable. Disable requires the Nvic. Okay, I'm not going to deal with this. I am going to take. Let's see what I'm going to do. It's 7:30 now. I've been streaming for like an hour. All right, I'm gonna take a quick break, maybe like 10 minutes, and then I'm gonna come back and implement a couple things that I know need to change about this, and then I think it's time to dive into some NRF52 interrupts because I have apparently some bones to pick with the NRF52 interrupts. So I will be back and see you in about 10 minutes. Thanks all for watching so far. Okay, so we're back. I can't see me yet, but you can see me. Or we will see each other at the same time, probably. Okay. So. What am I going to do? I'm going to play with the NRF52 HAL. So I need to do two things. I need to pull up the NRF52 HAL and clone this. And we need to add a cargo patch. And I never remember what the patch syntax is. Excuse me. It's not NRF52 HAL. It's 52 HAL common. I don't think I'll need to modify any of the 3.2 specific stuff. So we actually share drivers between the 810, the 832, the 840, and the 9160, inappropriately named, but we should probably change that soon too. I don't know what Veba means, but sure. NRF 52 HAL common. So let's patch that dependency and let's do a cargo build and see how that goes. Cannot find right. CD. What is this even called? Timer UART. What a terrible project name. Expected parameters. Right. Mask. There is a method for that. If I was using new versions of crates, I would have it. Is it unmask then? No, actually, I bet you this will work. And then now that I've actually initialized the data, let's unmask and nvic pend call to unsafe function. Yeah, now it works about the way that I think it should. Yay! Panicked at the disco. Let's delete the breakpoints, yes. Let's just continue. So I'll go bloop, send, panic, bloop, send, panic, bloop, send, panic. What am I doing? Control. So what I did is, because this interface is not super correct, basically if it gets here and it doesn't have access to the data, then it just says cool, then disable the interrupt, so I don't have to deal with that for now. And then once I'm done, then I actually re-enable the interrupt and then pend it. This is kind of a hacky workaround, but maybe this will be one of the things that we fix. I don't know why it's not new lining for me, but NR, whatever. Not here. So now I got my patch dependency. Now we're in the wonderful land where we are using a custom interf library. So what do I want to interrupt first? I could do a button. I could do a UART. A UART's going to be more complex because I'm going to have to think about how to do that. What are the traits? Let's look at embedded HAL, source, blocking, serial. Okay, cool. There is separate write. Is that the same as UART? There's no UART read? Is there maybe one in non-blocking? Serial. Okay, read and write. Which embedded HAL digital to output pin? Sure. Do we just not have any of the traits implemented? Awesome. Cool. Go us. Being a leading okay, let's see. What could I do? What is this? Don't understand why that's the way it is. Ah, okay. Now I understand why it's like that. I'm gonna laugh if I end up right, if I was the one that wrote that, but okay. Okay, you know what? Let's first go and fix that. Let's fix the timer interrupt. Let's... Oh, not closing the whole... It's gonna complain at me. Why are you updating crates.io index so slow? Something holding a lock file? I have internet. It's not super useful. Let's Google. Updating crates index stuck. Doesn't help. Cargo trace, cargo build. Cargo registry. Burp. Huh, that's weird. I just want to see if it would build. Throw any warnings. I know it's gonna not build because I know that I need to set a feature and I haven't set any features. Cargo tunnel. Excuse me. No, that's right. I switched it to default the 858332 52832. Cool. Which Cortex M did it pick? 6.1. Cool. I'm surprised I didn't get any warnings on the pen, but okay. I want to change this timer interface. Because we don't actually need to enable the NVIC. When the timer reaches the value that is given as an argument to start. So I guess I don't need to enable it at all. What version was I using before? Panic, RAM dump, TWM, how that's fine. I want to actually see the lock file. Oh, I guess I didn't commit the lock file. Cool. Well, I guess I did, but it didn't change. Okay, whatever. I was wondering what version of NRF52 HAL it was using. I'm like 8.1, and what's the current version? 8.1. Okay, so I probably just have some changes in master. I'm actually gonna change this. Timer. See, this is going to be a breaking change if I do this. Why does... I'm confused because I don't know why enable interrupt doesn't throw an error, because this is an option env, and in my code, let's go look at, this is confusing me. Is there some kind of auto deref magic here? Or is it just late and my brain's not working anymore? Because I typed timer.enable interrupt and this builds. Now is it going to complain because now I've probably, no. What? I'm confused at my own code. Yeah, great. And what invoke? 8.1. Source timer RS 76. 76 in timer. But it is 081, which is the most recently released one. Yeah, Jonas, I had some weird lock file thing. Now I'm just trying to like figure out my own code. You can tell it's starting to get late because my brain's stopping to work. So I'm using, yeah, it doesn't state that. I'm using how common 081 line 76 in the how in timer 76. 76 is totally not this, so this has changed. Is my patch not taking? Cargo.toml. Where did my patch go? You all saw me edit the patch, right? Patch. What did I patch? Oh, I patched panic RAM dump. That's not super useful. NRF 5.2 how? There we go. 1001. Oh, right. Now the DWM is going to be out of date because DWM hasn't been updated to use the newest version. Cool. Braun Robotics. What? Move to Braun Embedded. Oh, okay. Braun Embedded. I think this is where everything lives now. So let's pull this down and let's patch this into. I end up, like, this is one of those difficult things about working from the highest level is that you end up needing to patch everything when you fix it. So let's go ahead in here and let's go ahead and patch DWM 1001. Version mismatches the story of embedded development. Yeah, I mean, you know, DW 1000 I think is the name of the folder. CD, oh, it's Rust DW 1000. DW 1000. Excuse me. Okay, so this needs to be patched because timer X doesn't exist anymore. Now it's 889. Now there are different traits. W1000 source librs 889. What are you called now? Timer impl timer, where there's an instance. So what did you become? Pub trait instance. So it's probably going to be something like timer instance. Where do you get this from? Does it just import the entire prelude or something? Timer. Instance as timer instance. Oh, good. Constraint. Oh, the DWM hasn't been updated for this whole change. Oh, no. Are there pull requests open against this? Oh, nope, just mine from a long time ago. Cool. Well, this is going to turn into refactoring. Okay, let's just burn. We're here. If we don't do it, no one else will. So, you're at 0 constrain. URT. Okay, let's go find all the constraints. So the way these actually work now is this is going to be probably something like you already knew the peripheral, then the configuration. It's probably going to complain because, oh no, maybe not. Okay, we do pull in these things. Cool. Not found constrained. So let's just make this twim new twim let's just go fix all the constraints. P0 doesn't have split anymore. Okay, cool. What does it have? 5.2 how? GPIO. Pin. Split? No? How do we obtain pins now? Parts. P0. Okay. Parts new. Okay. GPO from the upstream GPO definitions by defining a trait. Okay. Okay. What I probably should be doing is, nah, this is already here. does not have these features. Okay, whatever. This is gonna take a second. I think it's just parts. But let's look at the docs. I will be back while this builds. Have I mentioned how frustrating it is to wait for pack crates to build? Because Cargo Dock has gotten so slow lately, and we just have so many docs to generate. It makes such a big build folder. It doesn't help that my CPU is currently being eaten by video encoding, but you know, it happens. Eventually I should move my server in here and just do the streaming or the encoding or whatever on my server, or at least the building on my server and maybe the encoding on my laptop. Pains of development. Although on the plus side, I did realize that this isn't going to be a breaking change because we've already essentially have breaking changes. We just haven't published the 0.9 release yet. So any breaking changes I make now are actually totally okay to make. Okay, what do pins look like now? GPIO. Because I don't have a public GPIO object, so I just have P0. Oh, it's just going to be a method on P0, isn't it? Parts. Do I just... Okay, this is all the parts. New. Oh, I just gave it a GPIO P0. Cool. Alright, let's go back to unbreaking things. P0 split 508. Give you lib 508. I want to do parts new parts new p.p0, and then that probably has a split method, I would think. No, it's just, well, it's just this now, isn't it? And that's probably going to complain, I've broken something else around 806. because of, oh, all right, we've got failable traits now. Cool. Dot unwrap maybe. But it's void type, so it can't fail. NVIC 915 NVIC. I still don't think this should be this, but mutable reference to an NVIC. 923 disable interrupt some parts, right? Because that's not going to be GPIO parts. What do you not? No parts in GPIO. Where are you? You're in P0 parts. Okay. GPIO P0 parts. Not in there. Why are you not watching? Oh, because I'm in the wrong directory. I thought I had one that was just in common. No, that doesn't work. Yeah, it's getting late. Cargo build. NVIC, mutable NVIC. 894. Oh, it's already an NVIC. Oh, okay, cool. No result that must be used. Okay, yeah. 810. There's new traits coming anyway. 58 source main. Excuse me. All right, these don't have constraint methods anymore. Right, so these are not constraint methods anymore. This is going to be like timer new. This is going to be RNG new. This is going to be timer new. Yeah, you don't know what these types are, do you? Do you how timer URD RNG and interrupt some again I don't agree with this, but cool. Now you're running with the newest git add -I update git commit working with newest nrf52 how. I should probably make these submodules so that they actually work, but I will do that later. Okay, now we have a sane environment, but let's go change this timer stuff because it doesn't need to be like this. I'm going to change this. So it will also be enabled there outside this function. This is going to be this is just going to be unmask in nvic. We don't even need you to hand this. nvic bool if boom, doesn't require a parameter anymore. Disable interrupt. Disable. You're going to become mask in nvic. Bool. Someone even updated this so that it didn't throw a warning anymore. But we don't need the nvic anymore. Cool. And that's going to break DWM 1001. nvic. Doop doop. Wait for interrupts. What is this? Disable interrupt. True. True. Do we even need the interrupt anymore? We don't need this anymore. No, we sure don't. Let's get rid of that. Wait for interrupts. Yep, complain. Close other tabs. Close without saving. We need to be back in our actual original program, which is around here somewhere. Enable interrupt. False. Do not. Now we can actually do nvic mask interrupt timer 1. Let's do this before this, and then we can unmask, and now we can get rid of all of this shenanigans. So now we should get a crash. Try it. I don't know why that isn't line returning. It really bothers me. What are you gonna do though? Okay, well, that's working. I felt like I needed to change that in 2 places, but maybe not. And I'm actually, I guess this is an external function, so 2 gotchas. Using this method, any interrupt, even those unrelated to the DW1000, the method disable interrupt handlers. No interrupt handler will be called while this method is active. Why are we doing this? Okay, cool. I don't know what you're doing here, Hano, but you're doing something. Okay. Some bits are mostly stable. Physically unclonable function. I asked, what is a puff? The idea is that when RAM starts up, some bits are mostly stable, depending on unique physical impurities. This allows supposedly unique keys if you can spare a RAM region. Physically unclonable function. Naively, I'd implement this by power cycling many times and assigning stability probabilities to bits. Uniqueness proofs seem a bit expensive, though. Interesting. Okay. So we have this. We've changed this so that it doesn't require NVIC access anymore. So that's already good. Yeah. Let's see. UART is going to be interesting because I want to be able to just set it and forget it. So I'd like to have like an auto run version that gives you access to the like I'd like something that's like consumes the UART and gives you back something that's interrupt driven. But I need the ability to set certain interrupts. Question is, what interrupts do I give it? I'm going to pull up my data sheet. NRF 52832. Let's look on my product spec. No, this is the basic. I want URD. URD with easy DMA. Easy DMA. What are my events that I can get? Because events are basically anything that I can clear send NCTS events RX DRDY end RX TX ready and TX error RxTO. I still don't know what an RxTO. RxTO event. This is possible because the UART is, even after the stop RX task, that you're able to receive bytes for an extended period of time. Oh, right. Could you send the stop task? Depending on the configured baud rate. Yeah, I need to figure out what events I'm gonna handle. But you know what? It's 8:30 and I think I'm done for this stream. It's been 2 hours. It's been a good stream. And my brain's starting to go, and I feel like tackling this is a new thing. So actually, you know, before we wrap up, let's do one last thing. And there were comments in my... That's something that my brain can wrap around right now. I can go to panic, ram dump, this one, and Emil made some good comments, like things could be aligned. Let me pull up panic ram dump. We're just gonna finish with that because that's where my brain is right now. Let's see. Start pointer cast right, unaligned, because we could technically be in an unaligned position. This is at line 80. Check for alignment or use right unaligned. So I should have almost all of these. Copy, non-overlapping. These could technically be, there's Rust, putter, copy. These are allowed to overlap theoretically. Read, where are all the unaligned? There's read unaligned. Yeah, so read unaligned, do all of my rights, are all of my rights unaligned? Right unaligned, right unaligned. Cool. Now it doesn't matter if they're aligned, doesn't matter if they're overlapping. There is still one big soundness hole in that if you have a region that's too small for your panic message, we're not going to write this. So actually what I'm going to do is give you I'm going to give it to you in bytes, if any. So I'm going to do two things. I'm going to change this to static U8 because then you can't write it directly as UTF anyway, so it's kind of on you to handle this. This method may possibly not return valid UTF-8 if the message was truncated before the end of a full UTF-8 character. Care must be taken before treating this as a proper stir or stir. If a message existed, this function will only return the value once, and the message and the value once. Subsequent calls will return 0. Will return none. I'm not in C anymore. I'm probably good to just, so if the so basically when I do this once, I want to clear the magic word so that you only get the most recent boot. Although if you forget to check it, you're going to get an old boot, but there's really nothing I can do about that because I can't enforce that you call something on boot, but I assume that you're probably always going to check for this. So yeah. So where do I write facade? Start facade. So I have my start pointer. Clear the magic word to prevent this message from sticking across multiple boots. So this all is still good. That all worked. I've implemented the right unaligned, read unaligned, read unaligned, right unaligned. Why bother with UTF-8? GF being serif, it makes it ASCII only. Optimize if we want. Sounds like a win-win. Okay, where is... I wanted to see if there's a way to... a reasonably embedded way to take characters that fit. Like, if I know I have 1,000 bytes, I want the first 1,000 bytes of valid string. But I want, yeah. I'll probably just do it on the get. I'll write everything, and then a stir from UTF. Does my UTF error give me without? I guess I could just do from UTF-8 lossy. Oh, valid up to. Turns the index in the given string up to which the valid from UTF input. Oh, that's good. Oh, yeah, that's exactly what I want. Okay. Okay, let's put this behind a feature. Let's do message bytes, which is always there. Get UTF-8 pub fun. This one's gonna return stir, and what this is actually gonna do, it says let's let bytes equals get panic message bytes, and then let's see, where is my error? We've got stir, use, we'll just use it inside of this function. Use core stir from UTF-8. Wow. From UTF, if match, match from UTF-8 bytes. Okay, stir or stir some stir error. See, this always returns error. UTF error. Some valid up to some from, let's see, would return okay. Cool. Match from UTF-8 bytes dot dot UTF error dot valid up to some stir error whatever. I'm not going to try again. Shouldn't be possible. Just return none. Cool. Okay, what does that thing? Cargo build. Yep. Expected ampersand U8. Doop. Expected slice. Found stir. Where's ram dump librs? From call to unsafe function. Isn't this whole thing unsafe? Deny missing docs. QMS you're taking treating. This is going to be totally the same, if any. If any invalid UTF-8 characters occur, the message will be truncated before this message. Before the first error. If a message existed, the function will only return the value on subsequent calls will return none. Yeah, that's fair. Deny docs. Save. Git management. Okay. And then this is going to be CFG feature equals UTF-8. So that we don't require that. Because there's probably all kinds of Unicode tables that we may or may not want to include. So let's go to cargo toml. Not this clear. Yeah, okay. Features default equals this. UTF-8 equals that. It was what I called it, right? UTF-8. Features UTF-8. Because now it'll give me a different one. No get panic message. Cool. Cool, cool, cool. I'm actually somewhat interested in cargo build release. Panic ram dump. UTF-8. Panic message bytes. So let's just get the bytes because we are getting the bytes anyway. Panic message bytes. Do that. Get panic message bytes. Oh, right. I need to include the right one. Let's just pull in this. Okay, and then arm none yabi size target thumb release timer UART. Okay, and then let's go get the Let's go to our cargo toml for this and random features equals UTF-8. And then in our main, let's do UTF-8. Build release. Size. Is there a noticeable difference? Text. Yes, this increases the code roughly 1 kilobyte. 1 hex. Or no, just 1,000 bytes. So yes, there's a saving of 1K of excluding that UTF-8. So, good call for I'm sure there's other things at play, and if I had a totally bare example without that, but whatever. So let's go to my cd panic ram dump features right unaligned copy, because the copy non-overlapping is kind of obnoxious because a panic message should theoretically never overlap with the old message, but I guess in some case you could probably have a case where like you were panicking because of this panic message, and maybe it could be overlapping. I would think not though, because this panic message is probably going to come from Flash, but whatever. I'm also not worried about the performance difference while we're panicking, so don't have a huge panic message. So this became bytes, panic message. I do a read unaligned, clear the magic word. Cool, let's do a cargo format just for good. Git commit. Implement unaligned read writes. Add UTF-8 functionality behind a flag. Git push origin fancy. Let's go comment on our pull request, and that's gonna be a day. Implemented unaligned pointer methods at the real prof, put changed function signature to return a byte slice, added an optional UTF-8 feature which enables checked UTF-8 strings in a totally non-scientific test. This feature seemed to add 1K to the, oh no, build failed. Why did build fail? Where's, no, Travis CI, why is this? I just want to see the failed build. Is there a merge conflict or something? The build failed. Why did the build fail? Did I forget to commit something? Burp, burp, burp. Oh. Get out of here. Let's just pretend that never happened. Okay, where's the pull request? Did I just bounce off the pull request while I was writing a comment? Okay, good. To the code size. What is this? What is my configuration? Cargo toml. Am I opt level 3? At opt level 3 before text after without UTF-8 with UTF-8 before. Okay. Let's copy this. Was also tested on the NRF 52832, specifically on this stream. Should be ready to merge. If you don't want it here, I'll fork this and make another crate as is. Okay. It's interesting that it's exactly 1,000 bytes, which makes me think there's like exactly 1,000 bytes of code points. Well, my brain is toast now. So thank you all for watching. I hope you enjoyed. Code size might increase a lot with unaligned operations. Jonas, the unaligned operations were before that change. I could go back and change the unaligned operations, but the unaligned stuff is incorrect. I could theoretically throw an error if you didn't have an aligned section, but I'll let someone else add that as a feature. Anyone else? No one else has commented, so thank you all very much for watching. Hopefully I'll get to do this more often. Maybe I'll actually get in and make some NRF 52 changes next time and implement some interrupt stuff, but hopefully this has still been interesting, and I will catch you all next time. Thanks for watching.